In this problem, we have a simply supported beam under an offset point load P. There is a pin at A and a roller at B. And the total length of the beam we might call L. And the total length of the beam is equal to A plus B. Okay. And what we want to do is find the reactions at A and B. So the first thing that we're going to do is to draw a free body diagram of the beam. So first, let's draw the beam itself. And I'm just going to do it freehand. Okay. And there's the beam, sort of shaded in here. And then what I'm going to do is draw the forces that act on this beam. And there are several forces. One, of course, is the load P. Now, the pin at A can resist motion up and down, so it can do that with a force in the y direction, and it can also exert a force in the x direction. At B, we have a roller, and a roller can only exert a force normal to the surface that it's rolling on. And so we'll draw this up, and we'll label this BY. And remember, we already have a coordinate system on here that looks like that. So now what we're going to do is apply equilibrium to the free body diagram of the entire beam. And right away, you can probably see that the sum of forces in the x direction 0 implies that AX is equal to 0, since AX is the only force in the x direction. Okay. Now, the next equilibrium equation we can apply is sum of forces in the y direction is equal to 0. And that means that AY plus BY minus P is equal to 0. Now the problem with this equation is there's two unknowns in it. And even though we can probably do the math for two unknowns, two equations, two unknowns, it might be easier to come up with an equation where we only have one unknown in it. And we also have to come up with another equation because we actually have three unknowns, three reactions. So I want to take a moment about one of the supports. So the support I'm going to take a moment about right now is A. A moment's about A. And any moment that is counterclockwise is going to be a positive moment. Positive. All right, so if I look at point A, P is A away from point A. And it's causing a clockwise moment around point A. So this is minus P times A is the moment caused by point P. And BY is the entire distance or the entire length of the beam L away from point A. So it's plus BY times L is 0. And so BY is equal to PA over L. And if we repeat sum of moments about B, we will find that AY is equal to PB over L. And we're done.